Okay, this is the third and final in the series of organic chemistry. We're going to be looking at chemical properties and chemical reactions and so on. Now, there is a whole stack of information that you guys need to get your head around in this particular section. We're going to be putting a whole little summary sheet. It's probably not on the website just yet, but give it a couple of days and you'll be able to download the full summary. But just remember that getting to know organic chemistry is like getting to know a family, and there is no other way to get to know your family than by spending time with them. So get to know your organic questions really well. Make summary sheets by all means if you want to do that. It helps. But the best thing you can do is just do questions, and you'll get to know it like the back of your hand. So organic reactions, there's basically 6 types of reactions that can be done. I'm just going to give you a quick overview and then go through a couple of details on each. I'm not going to go through too much detail though. The first type of reaction we can have is a combustion reaction. Oh, fantastic. Substitution reaction, addition reactions, and then the opposite of addition, not subtraction, elimination. Those are the main 4. Those are the ones we're going to spend most of our time looking at. And then there's 2 others that you will have to get to know: esterification and polymerization, which I'll just briefly explain at the end of the whole setup. So let's have a quick run through. Combustion is not tricky. The awesome thing about it, I mean, it appears all over organic because organic chemicals are very combustible. So everything from the petrol and the diesel that runs our cars through to the acetone that we were talking about earlier that takes your nail polish off, that's going to go up in a ball of smoke pretty quickly. So whatever organic compound is combusting, in other words, reacting with oxygen, big flames, all that kind of thing, that's what combustion is all about. We are expecting, there you go, all right, the same output. That's the awesome thing about it. So no matter what we have, we burn it with oxygen and we can get the same output, same products, carbon dioxide and water, and a whole lot of energy in the process. Okay, so that's the easy part. The hard part is perhaps balancing it. So let's say a question was write a balanced reaction for the combustion of octane, which is the main alkane that was in petrol, for your interest. So let's have a quick look at that one. Octane, C8H18, plus oxygen, is going to give us some carbon dioxide and some water. Okay, so pause the video, you try it yourself, but I'm going to crack straight on and have a look at how we would do this. Now, what I'd recommend with balancing, and some of you might feel like you need some practice with balancing, definitely something worth doing, is I wouldn't bother with all the lists and stuff. They can work, but they tend to be quite cumbersome and they take a lot of time, and you're bound to make just as many mistakes as if you do it by sort of trial and error with a pencil. One trick is, if you see anything that appears in more than one compound, leave that till last, okay? Work with things that appear with only one thing on either side. So let's start with C. There's 8 C's on this side, there's only 1 on that side. So if we put an 8 in front there, that'll sort that out. Cool, so far so good. 18 H's, well that's an H2, so we've got to factor that down, so we'll put 9 H's. So far so great, we've got that balanced, and these are looking good. 8 times 2 is 16, 9 times 1 is 9, 16 plus 9 is 25. We've got a bit of a problem here, because we can't put 25 there, because that's an O2. So we're kind of stuck. So then you think, well, what could I put there? Well, I'd have to put like 12 and a half. But you obviously can't have a half coefficient. So then all you have to do is just multiply throughout the whole thing by a factor of 2, and that is going to sort it all out for you. So 12 and a half times 2 will give us that full 25 that we were looking at just now. Multiply that by 2 as well. 8 times 2, 16. 9 by 2 is 18. And there is your balanced reaction. Okay, do practice some others, but that's about as hard as it gets. So that's combustion. And you have to know some LO3 kind of questions about, useful for fuels, but watch out for greenhouse gases and all that kind of thing. Substitution, it's a very straightforward process. It's like substitution in any kind of sport. where you got rugby, soccer, netball, basketball, whatever it is. One player comes off the field and one player goes onto the field. And that's as easy as that. So you've got your kind of, it's usually a saturated compound, let's say ethane, and then we're going to sub off the H player goes off, and on comes something else, like a Br or an OH or something like that. There's your substitution. Then addition, we're actually now adding something into the molecule. So let's have a look at a compound. Now you've got to have somewhere to put it. You can't just stick it onto a saturated molecule. You need an unsaturated molecule, one that has room. In other words, it's got to have a double or a triple bond somewhere. So let's take ethene, and we could add in, say, Br2. Okay? So what's going to happen is the double bond is going to break. That's going to create an extra bonding point on either of those C's, and that's where the Brs join in. So we would end up with something like that. That is an addition reaction. Now, addition is where you need to now know the type of addition or the name of the reaction. So addition is the general type of reaction, and then you get something like this where we're adding in a halogen, and that is halogenation. Or if we added in an HBr, that would be hydrohalogenation. Or an H2, hydration, H2O, hydration. No, sorry, hydrogenation for H2 and hydration with H2O. So I'm sure you've got your head around those. If you haven't, check your notes and find your way around. That's addition. Elimination is the exact opposite of it. Instead of adding something in, we're taking something out. And so we'd start more saturated and end up less saturated. So perhaps fully saturated to a double bond somewhere. One little hint, when it's going this way, you're going to start with more reactants becoming combined into fewer products. Elimination is going to end up with fewer reactants, but as you break things apart, you're going to have more products. That's the way that you can identify those two. So get to know those names, and we'll do an example just now where you'll get to see that in context. Esterification is making esters. Acid, carboxylic acid, plus an alcohol will give you an ester plus water. Revise it. I'm not going to go through any more detail than that. And polymerization, I don't think many of you would have done this yet, but it's about making polymers, obviously. And polymers are plastics. It's about joining chains and chains and chains and chains and chains and chains and long chains, thousands of molecules long, to make all sorts of interesting things. So that is a quick overview of things. I would like to do a worked example. That's probably the best way to get your head around this section. So we're going to have a look at the 2014 paper. That was a typical kind of organic reactions question. They love these flow diagrams. You'll see them all over the place. And they link one substance to another, and you've got to name the process and name the catalyst and do balanced reactions and all that kind of thing. So let's have a look. It's in your workbook. Question number 4 of the 2014 paper. The flow diagram below shows the preparation of different organic compounds using CH3, CH.1, CH2, in other words, propene, as a starting material. X, Y, Z, and P represent different organic reactions. And then they've given us the flow diagram. To which homologous series does propene belong? Now, they haven't called it propene. You identify that it's got a double bond, so it's obviously an alkene. Okay. 4.2, there's 4 parts here. Write down the type of reaction to which X, the type of reaction of which X is an example. So, just so you can have a look on the video, but I would like you to download it. This is our alkene, that's our starting point. Okay, then X is making this substance here, CH3, CHCl, CH3. And that is the reaction that it's going to go through. The type of reaction of which X is an example. Now, we've broken the double bond and we've added stuff in there. It's an addition reaction. That's the simplest answer, and you could put the more specific one, but you're not going to get any brownie points for that, okay? The actual specific one is what? We've added in an H, an extra H, and a Cl. Yes, okay, so there's the extra, so it's a hydrohalogenation reaction. 4.2.2, write down the structural formula and IUPAC name of the alcohol produced during reaction P. So reaction P, for those of you who haven't got the paper open there in front of you, they take this one and make it, and they just call it an alcohol. Okay. So write down the structural formula and the IUPAC name of the alcohol produced during reaction P. Well, just as a matter of interest, what type of reaction would that be? Yeah, we don't have to answer that one, but just for our interest, type of reaction, well, the thing that's going to get taken out is the Cl, okay? And an OH is going to come in. So it's actually just one player on, one player off, substitution reaction. To draw the structural formula, now this is an important thing. When you're drawing structural formulae, make sure that you put in all the bonds. Don't summarize things like, for instance, you might be tempted to do that in place of the Cl. I'd recommend do the full thing, an O with an H. Every single bond must be noted. Don't leave stalks without H's on them. Don't combine your CH3s at the end or anything like that. That would be your structural formula. And the name, 1, 2, 3, prop. Propan, it's an alcohol, so it's an ol, and the ol is on the second one, so it's propan-2-ol, or 2-propanol. All right? The type of reaction of which Y is an example. Now, Y requires some H2SO4, we're told, and some of you might suspect what is going to happen here. Alcohol plus H2SO4 is going to give us an alkene. And to complete the diagram, there is in fact an alternative route, which is reaction Z. So the type of reaction of Y is an example. Well, it's elimination, because we're going from that back to the alkene that we started with there. So you could call it elimination, or if you want to be fancy, it's a dehydration reaction. We're taking out an OH and an H. All right. The function of the acid in this particular reaction, well, it's the eliminating reagent, or it's the dehydrating reagent. Okay, that is question 4.2. 4.3, for reaction Z. For reaction Z, name the inorganic reagent needed. Now, just before we get into this, I want to point out this particular little pair of reactions. This comes up all the time. It's probably the most popular chemical reaction difference that is tested. We take the same compound, in this case 2-chloropropane. It's a haloalkane. And we can do two things to it. And in fact, we can actually use the very same substance in both cases. All that we adjust is the conditions under which that reaction takes place. So they ask for the inorganic reactant or inorganic reagent needed to do this. That's what they're asking for. That is, in fact, let's change the color, NaOH, or in English, NaOH. Okay, so NaOH is the inorganic compound. Now, in fact, we could use that very same one here, but just do it under different reactions, and it's going to give us a substitution. So the next question goes on to say, well, two reaction conditions needed in order to get that reaction to occur as opposed to this one. Now, the difference between them is the fact that in order to eliminate something, you have to treat it a little bit more harshly. Okay, so I don't know if you've ever watched that Missing Link. No, what's Missing Link? What's it called? The Weakest Link. The Weakest Link TV show with Anne Robinson, the lady with the red hair, and she's wild and she's rude and she's mean, and she will just drill you down in front of everybody, millions of viewers, and she makes you feel about this big. I've never been on the show, but I can just imagine. So she eliminates you from the round, and it is harsh. Okay, so under harsh conditions, elimination will occur. So let's imagine the harsh conditions. What are we going to do with the NaOH? Well, it's going to be concentrated. All right, strong. And we're going to heat this baby. All right, so those are the reaction conditions. under which we're going to get elimination to occur. To get meek and mild substitution, all you'll need to do is use dilute NaOH and warm it gently, and then it will just substitute as opposed to eliminate. All right, so that is a very good example. It comes up all the time. How can you make a different thing happen with the same ingredients? Well, you just change the conditions. So those could be two of the conditions, and the third one, just as a matter of interest, is to get that and that to mix, you have to put it in a solution of ethanol. All right. And then lastly, 4.3.3, this is a gift, absolute gift. All the other questions have been like 1 mark or 2 marks, 3 marks. This is 5 marks, and it's so easy. It says, write down a balanced equation for the production of the alkene using structural formula. So we've been talking about reaction Z, so that's the one that they're wanting us to do. So I think I can squeeze in at the bottom there, hope you guys can see it all right. Balanced reaction, getting from there to there using structural formulae. Okay, so here we go. Let's get some points here. Okay, so C, 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 Cl in the middle, and H is all the way around. Okay, so far so good. That's going to be added to NaOH. It's an inorganic compound. You don't have to worry about any stalks and making it into a covalent bond because it's not covalently even bonded. Then what happens? Okay, elimination occurs. The Cl taken out, the H taken out. Then we're left with a double bond. So we've still got the CH3 on the end. Then we get a C double bond C, 1 H on that one, 2 H's on that one. Now the Na stole the Cl to make NaCl, and the OH stole the H to make H2O. That little simple chemical reaction is worth 5 marks. I think, let's just see, we get 1 for that, 1 for those, and then I think 2 there and 1 there, or vice versa. But basically, if you've got all that detail, you've got your 5 marks. So that's a gift on a plate, and that is the kind of question that you get with chemical reactions. So there's a bunch of them. They're all quite similar, but if you can do this kind of thing, and as I said, get to know the family, spend time with it, spend time with them, and you will become a genius at organic chemistry. Good luck. Cheers.